Hey y'all, here's the experiment that we ran earlier in the semester. This is a environmental policy experiment that looks at opportunity cost. It simulates a group of business firms that are being regulated uh, over their emissions, and they are make supply decisions in two policy regimes. One is a tax regime, and the other one is a um, trading of pollution permits. So this paper, or this experiment, is described in this paper by Holt et al., Teaching Opportunity Cost and Emissions Permit Market, and this is linked on As You Learn. The authors are Charles Holt, Erica Myers, Marcus Rake, Svante Mandel, and Dallas Bertraw, with apologies to anyone whose name I butchered. Okay, so you can take a look at how the game is supposed to be played. I think we did a pretty good job of that on VEcon Lab. And it explains that business decisions are supposed to be similar under both regulatory regimes. Now, the useful thing with experimental economics is that you can have a theoretical result that predicts similar behavior under regulatory regimes, but you can test it out in a laboratory setting and see if that holds true. So I'm going to log into my VEcon Lab account, and we're going to look at those results. So this is we did this on Valentine's Day. We're going to view an ongoing experiment, and we're going to look at the results. So let's see if I can arrange this thing so everyone can see what's going on. So over here on the left is the price. So I'm going to cut off the labeling of the graph. And so there were 16 rounds in the game. Lab participants, which were economic students, environmental and resource economic students, were faced with a price that ranged from $1.50 up to $8.50, and they faced a cost of production. There was a fuel input, and then there was the cost imposed by environmental regulation. And the quantities that the business firm could sell in order to maximize profits range from 0 to 1 to 2 to 3. Okay, in the first treatment, there was a pollution permit. It cost $3, but each business firm was endowed with 2 pollution permits. So if you wanted to produce 3 units of the product, you had to go into the permit market and buy a permit for $3. If the price of the good was low, such that you did not want to use all of your permits, let's say you wanted to produce 1 unit of output, that means that you would use 1 permit and you could sell the other one, then you could sell that in the pollution permit market for $3. And those decisions were made automatically for you based on your quantity choice. So these blue dots represent the average quantities produced by each business firm at various prices. And this is in round 1 of the experiment. I'm just going to click on the Show Next Round button and see how these decisions changed over the rounds. So in round 2, round 3, 4, 5, 6, 7, and 8. So the dots begin to organize themselves into something that looks more like a supply curve that you may have seen in a previous economics course. So the blue dots represent increasing quantities as prices go up. Okay. In the second treatment, let's look at the second treatment. So the permit price again is $3, but the permit endowment is 0. So this mimics a emissions tax, where for each unit of output that you want to produce, you are charged $3. You have to buy a permit, you're charged $3, and then you can produce that unit of output. Now, this is an opportunity cost experiment because in both of these treatments, the cost of producing each unit of output, in addition to the fuel cost, is the $3 permit price. Either in treatment 2, you either have to purchase the permit for each unit of output that you produce, but in the first treatment, you can always sell your permit for $3. So that's the next best alternative use of your permit. And so the cost is the same whether it comes out of your pocket or goes into your pocket in both treatments. So that's why the experiment is, the theoretical prediction from the experiment is that the supply curves will be the same. Let's see if they are. So here's round 1, and we have roughly an upward sloping supply curve. Round 2, 3, 4, 5, 6, 7, and 8 was the last round. And so our supply curve doesn't look as nice and neat as in treatment 1, but is still upward sloping. And if you recall, in treatment 1, with the endowment of the permits, all of our supply decisions, the average supply decisions at the lower prices were all about 1 unit, and these are all closer to 0 when we're face the tax. So the question is this a different supply curve, these red dots versus the blue dots? Okay, so let's go back to treatment 1. So there's the blue dots, and treatment 2, there's the red dots. So it looks like there's a difference. So our experiment may have identified a difference in economic behavior imposed by different regulatory regimes, even though we didn't expect that. So that's something that a regulatory authority would like to know, and would like to know if there's different costs associated with those. So I have downloaded the data, and I have put that into SPSS. So here's the data, and we've got, I've cleaned it up. We've got variables for the different round of the experiment. Rounds go from 1 to 16. The ID number of the respondent, the price, the randomly assigned price assigned to this respondent in different rounds, whether the person was under the permit regime equal to 1 or under the tax regime where permit is equal to 0, and then the quantity decisions made by the survey respondent or by the experimental participant is in this last column. So 1, they sold 1 unit, sold 2 units, 0, 0, 1, 0, 2, and so on. Okay, and I've set up a filter over here. I've randomly selected 50% of these data to do the analysis, to illustrate the analysis, so that the results that I'm going to get in this video are different than the ones that you'll get when you do the data analysis yourself. Okay, so what I want to do is try to estimate those 2 different supply curves. So I want to get actual numbers instead of just looking at blue dots and red dots for different quantities and how they vary by price under different regulatory regimes. So one way to do that in SPSS is to go to the Analyze tab, and we want to compare means. And there's a bunch of statistical ways we could do this. This isn't a stats class. We're just trying to learn a little bit of economics. So let's just click on means. And here we have a dialog box. And we are looking at the compare means box is wanting dependent variables and independent variables. So our dependent variable is the outcome. It's the decision made by the experimental participant, and that is the quantity sold. The independent variable is the primary determinant of that quantity. And from basic economics, that is the price of the product. Okay, and so I want to see how that varies by the regulatory regime. So I'm going to click on Next, and that gives us another opportunity to look at a different independent variable. So layer 2 is what SPSS calls it, but this will just differentiate those supply curves by regulatory regime measured by our permit variable. Okay, so I'm going to click OK. And SPSS has conducted some analysis. So this tells us we've got 939 respondent or data points, and the mean, the average quantity is in the mean column. The sample size, the number of surveyed experimental decisions is in the N column. We're going to ignore standard deviation. It's a measure of spread around the mean. Okay, the first column is the price, so that goes from 1.5 to 8.5. And then the mean, the average quantity at each price, is differentiated by the regulatory regime. So when permit equals 0, that's a tax. That's an emissions tax. When permit is equal to 1, that is an emissions permit regime. So here's the numbers that we're looking at. The average quantity sold at a price of 1.5 is 0.33 when there's an emissions tax. The average quantity sold when there is an emissions permit system is equal to 1. So there's a difference there. When the price goes up to 2.5, we get about the same amount of difference. When the price goes up to 3.5, the supply under the tax scheme is about the same as when the price is lower, but the price begins rising when the price goes up to 3.5 under the permit scheme. Okay, when the price is 5.5, we get another difference in quantity. When the price is 6.5, the difference begins to get smaller, 1.91 versus 2.00. And at 7.5 and 8.5, we again don't get much of a difference. Okay, so with these numbers, I want to plot different supply curves. Okay, so let's see if I can get that output over here so I can take a look at it. And I try to copy and paste the image. That did not work. Okay, so I'm back. I stopped the recording to figure out how to do this on this machine. So I'm going to right click, copy special, and copy this as plain text. Click OK. Go back over here, and I'm going to paste this, and there's some numbers that I can play with. So I'm going to draw a graph to help us organize our thoughts and try to figure out how to estimate some policy cost of going with a tax regime relative to a emissions permit regime. So in general, it looks like the supply curves that resulted from the behavior exhibited in the experiment look like this, where up here with when the price is getting higher, the supply curve's getting closer than down in this area where there looks like there's more of a difference in behavior due to different regulatory regimes. So it's this gap in the two supply curves we want to measure the difference of. The height of the supply curve measures the cost imposed on the business firm, and what we're seeing in the experiment is that there is some perceived cost associated with the tax regime relative to the permit regime. Now, as we've seen in class, there are real costs imposed on business firms due to a tax, because business firms have to pay more money to government and their profits are lower. But still, there shouldn't be much difference in the supply decisions. So as the research project, the idea of the research project is to estimate the differences in these numbers and then report that as the policy outcome that we have measured. So let's, okay. So let's draw this again, price and quantity, and let's actually calculate the regulatory costs for a couple data points. So let's look at when the price is 1.5 and when the price is 2.5. Okay, when the price is 1.5, our supply decisions are 0.33 and 1.07. Okay, so 0.33 and 1.07. The supply curve with the tax is the black dot, and the supply curve with the permit is the green dot. Okay, when the price goes to 2.5, the decision's about the same, 0.38 and 1.5. Okay, the black dot is 3.8 and the green dot is 1.15. Okay, so what I want y'all to do to estimate the area in between these supply curves. So for each difference in prices, you are going to have a trapezoid where we have a height, call that H, and then we have two different bases of the trapezoid. Let's call that B1 and B2. So the area of that trapezoid, call that A, is going to be equal to B1 plus B2 divided by 2. So the average base times the height. Okay, so the height for each change in price will always be equal to 1. So that simplifies the analysis to B1 plus B2 divided by 2. And B1 is the difference in the quantities, the means that we have estimated at each price. So B1 is equal to 1.15 minus 0.38. And then B2 is 1.07 minus 0.33. And then the average of that is the cost of the policy. Okay, so I'm going to get out my calculator and figure out what those are. So 1.15 minus 0.38 equals 0.77, and then 1.07 minus 0.33 equals 0.74. Okay, so 0.77 plus 0.44 equals 1.51. And divide that by 2. So the cost is 7.55 in that first chunk of the supply curve. And I got my decimal in the wrong spot. .755. Okay, so let's calculate another one. See if I can move this guy over. So we're going to get something similar. Let's look at going from 4.5 to 5.5. So the two bases of the triangles are the differences between the means at each price. Okay, so the area is equal to 1.8 minus 1.28 at a price of 5.5 plus 2 minus 1.91 at a price of 6.5. And all of that divided by 2. Get my calculator out again. So 1.8 minus 1.28 equals 0.52 plus 2 minus 1.91 equals 0.09. So 0.52 plus 0.09 equals 0.61 divided by 2. That's equal to 0.305. And so as the difference in behavior narrows, the higher we get on the supply curve, the cost imposed by the policy gets less and less. Okay, so the results come in two forms. There's a graphical depiction of these costs. Okay, so the supply 1 and supply 2 need to be graphed out according to the averages that you have computed from SPSS. Okay, and then the cost is equal to the areas at each price difference. So the area we calculated between prices of 2.5 and 1.5 was equal to 0.755. And then the cost that we calculated in the area of 6.5 and 5.5 was 0.305. And so the sum of those two areas is 1.6560. I think that's right. And then we would do this for each pair of prices.